class, this is Professor Smith. I'm going to be doing a movie on sketching the graph of y equal a sine bx plus d or y equal to a cosine bx plus d. In this example, we're given the cosine function, and what we notice that's different about the last example we did where we had a phase shift, you'll notice that there's a subtracted 1 on the outside of our function y equal to -2 cosine 1/2 x. That subtracted 1 lets us know we have what's called a
horizontal shift.
If the subtracted 1 was within
Horizontal
the parentheses,
shift.
that would let us know that it's part of the argument, and that would be a phase shift. If you recall, the phase shift shifted the graph from right to left. Well, it turns out the vertical shift shifts the graph up or down. What's interesting with the
Horizontal shift
is that What's interesting with the horizontal shift is that it matches. In other words, since this is a subtracted 1, the graph is moved down 1. If it were an added 1, the graph would be moved up 1. However, with the phase shift, it's the opposite. If you have x plus pi over 2, then we know that the phase shift is the opposite of pi over 2. So with the horizontal shift, which moves it up or down, it lines up. All right, so what I do with this is I always pretend that my new x-axis is now this horizontal shift of y equal to -1. So what I could do is draw a horizontal line here at y equal to -1. So to do that, I'm going to capture this problem out on my iPad to show you how I would do it if I was using pencil and paper. So I've opened the problem up on my iPad. I've captured that the amplitude is going to be +2, and instead of starting at the max, it's going to start at the min because of -2 for the value of a. I also have that b is 1/2, so that means the period is going to equal 4 pi, and then d is equal to -1. That's that horizontal shift. That means our axis of symmetry is now going to be y equal to -1 compared to the x-axis, which is y equal to 0. Now that we have that piece of information, let's go ahead and find our x values for our key points. But just know that instead of those x values falling on the x-axis, now those values are going to fall on the line y equal to -1. So let's find the beginning, middle, and end. Since there is no phase shift, that part's a lot easier. We know that the beginning is going to be 0. We know that the end is going to be 4 pi. The middle is going to be half of 4 pi, which is 2 pi. And then if you want to find those quarter points, you take half of 2 pi, and half of 2 pi is pi, and 3 times that for the third quarter point will be 3 pi. So our interval is going to go from 0 to 4 pi, 2 pi in the middle, and then pi the first quarter point, and 3 pi the third quarter point. We know instead of this now being the x-axis, this is going to be the line y equal to -1. So let's capture that in this next screen that so here's the graph, and I'm going to use my ruler tool to draw a horizontal line at y equal -1. And so that's going to be my new axis of symmetry. I'll change the color, and that's y equal to -1. And then what I'm going to do is, remember, it crosses at the beginning, middle, and end, but now I'm not going to be on the x-axis where I would go from 0 to 4 pi, that's the end, then the middle, and then the quarter points. Now I'm going to draw those on the horizontal shift of y equal to -1. Let me write that negative there. Alrighty, so my points are going to cross at 0 and 4 pi in the middle. So the quarter points are pi and 3 pi. Normally it would start out at its max. Because it's a -2, it's going to start at its min, and it's going to be 2 away from -1. So 2 down from -1 will put me at -3. So it's going to start at -3, the ordered pair would be 0, -3, and it's going to end at 3 pi, -3, because it has an amplitude of 2. And at 2 pi, and notice I have my pen on the line y equal -1. I don't have the pen at x equal to 2 pi, but here at the ordered pair 2 pi, -1. So what I'm going to do now is, instead of going down 2 like we did at the beginning and the end, we're going to go up 2. So if you go up 2, that will take us to 1. If you add 2 to -1, you'll get 1. And if you subtract 2 from -1, you get the -3. All right, so now we have our graph. Oh, wait a moment. 4 pi. Oops, sorry. So now we have our graph. I'm thinking, it does not look right. There we go. All right, so let's go out to ALEKS and graph it. All right, grabbing my pen tool, I'm going to start at -3, and then I know at 4 pi it's also -3. At 2 pi, which is the middle, it's going to go up to 1, and then it's going to cross at the quarter points along the line y equal to -1, so at pi and 3 pi. And now that I've graphed those 5 key points, I can now select the graph function button, and there I have my cosine graph. Let's check our work. Woohoo, we're correct. So let's go ahead and do one more. So for our new graph, we have an amplitude of 3/2. We have a period that's equal to 2 pi times the reciprocal of 3/2. Times the reciprocal of 2/3, which would be 3/2. So we get a period of 3 pi. So let me show you that on my pad. So 2 pi divided by 2/3 really becomes 2 pi times 3/2. The 2's cancel, and that's what leaves us with the 3 pi. So that's going to be our period. And then let's take a look at our horizontal shift. So we have y equal to -2. So again, this one is shifting down. All right, so we know that we're going to mark off the beginning, middle, and end. So at 0, the end's going to be 3 pi. Halfway in between is 3 pi over 2. And then half of 3 pi over 2 is 3 pi over 4. And 3 times the first quarter point will give me 9 pi over 4, because 3 times 3 pi over 4 is 9 pi over 4. So those are going to be the values if I'm on the line y equal to -2. We know that the sine wave goes up on the roller coaster first because it crosses beginning, middle, and end if a is positive. In our case, it was. So from the line y equal to -2, we're going to go up 1.5, and then we're going to go down 1.5. So when you add 1 to -2, that's going to take you to -1. Add another half, that's going to take you to -1/2. Going in the other direction, if you were to take 1 away from -2, that would take you to -3. And then half again would take you to -3.5 or -3.5. And so now we can draw our graph. It's going to cross at the beginning, the middle, and the end. It's going to go up to -1/2, which is 2 up. It's going to go down to -3.5, and then come back to 3 pi. So let's go ahead and graph that out on ALEKS. I think doing a graph first on paper and then going to ALEKS, just like we've done, is so much more helpful, because then we can kind of see our ordered pairs. So we know that it's going to cross at y equal to -2 at the beginning, the middle, and the middle is 3 pi over 2. So pi over 2, pi, 3 pi over 2 is the middle, and then 3 pi is the end. And that's along the line y equal to -2. And then we know at 3 pi over 4, and again, each tick mark 1, 2, 3, 4. Each tick mark is a pi over 4, so 1, 2, 3 is 3 pi over 4. So at 3 pi over 4, we top up to 1.5 above -2. So if you go up 1 and then a half, that takes us to that -1/2. Then at 9 pi over 4, which is halfway in between, we're going to go down from -2, -1.5, or we're going to go down 1.5. Oops, I accidentally, let me hit undo. I didn't mean to put a dot there. So here I'm at 9 pi over 4. I'm going to go down 1.5 at 9 pi over 4, -2. So down 1 and then a half. So now we have that we're going up on the roller coaster, 1.5, down on the roller coaster to 1.5, and then back up. And again, the middle, beginning, and end, they all cross through the line y equal to -2, because that's our horizontal shift. Let's hit the graph of function button, and there we'll have several cycles of our graph going through the line y equal to -2. So I hope this movie on sketching the graph of y equal to a sine bx plus d, or y equal to a cosine bx plus d, was helpful for you. Bye-bye.